This is the screencast for section 3.3, example 2. Basic properties of logarithms. So my catchphrase for the log section is when the base of your log and the base of your exponents are equal, properties happen. Basically, if exponential functions and log functions are inverses of each other, when your base of your log and the base of your exponential function are the same, they have a lot of the same things happening. So we're going to learn more about why those work in class. For right now, assume that they work, and these are those logarithmic properties, and then we're going to look at some examples. So first of all, the log base b of 1 equals 0 because b to the 0 equals 1. Now you already knew that. So the log base anything of 1 is 0. The exponent that gets you 1 of any base is 0. Now, the log base b of b, so the exponent of b that gets you b is 1. The exponent of b that gets you b to the exponent of y is y. So the base of the log is b, the base of your exponent is b, therefore you can just write y. The base of your log and the base of your exponent are equal. Look at, there you go. Magical things happen, properties happen. This is actually saying what exponent of b gets you b to the exponent of y. Well, the answer is y. This last one is a little harder to explain. Again, we're going to go over this in class. But b, the base of your exponent, so your entire exponent here is log base b of x. The base of the log is b, the base of your exponent is b. That works out to be just x. We're going to look closer at that in class. So now we've got log base 2 of 8, which I know in the last example, Ms. Larson, we've already done this one. I get it. You looked at and you said, oh, what exponent of 2 gets me 8? The answer is 3. But what I would like you to practice here is manipulating what you're taking the log of to have the same base of your log. So for example, I have log base 2. I need to make 8 2 to the something. So I can rewrite this as log base 2 of 2 to the third. Now this third property up here applies. Log base 2 of 2 to the third. The base of my log is 2. The base of my exponent is 2. Therefore, that is 3. Part B, the log base 3 of square root of 3. So what exponent of 3 is the square root of 3? Well, that's 1/2. We already did that example too. What I want you to practice is writing log base 3 of, so square root of 3 is 3 to the 1/2 power. Therefore, the base of my log and the base of my exponent are the same. This works out to be 1/2. Now part C is that one that I haven't explained to you why it works yet. The base of my exponent is 6. 6 to the log base 6 of 11. The base of my log is also 6. So this is a simple 11. Number 5 is a little bit trickier, the now try problem. The base of my log is 5, so I'm trying to get the cube root of 25 to have a base of 5. So my first step, log base 5 of, I know that 25 is 5 squared. So I'm going to rewrite this as the cube root of 5 squared. Now, back from what we worked on with power and monomial functions, well, power functions actually, 5 squared, the cube root of that works out to be 5 to the 2/3 power. Now, the base of my log is 5, the base of my exponent is 5, the answer is 2/3.